Alright, we're going to get started on Chapter 1, Section 8a. We're going to continue with the inequalities. This time we're going to start quadratic inequalities. So to solve a quadratic inequality, it's similar to solving a quadratic equation. You want to first get 0 on one side and your quadratic on the other, and you're going to solve it as though it were equal to 0. Now the values that you get when you actually solve it, we're not going to say that those are your solutions. You can't stop there once you get those values. I'm going to call those critical points or critical values, right? So those are the points where we're going to have to divide our graph, our numbered line, into different sections, and then you're going to see that there's going to be solutions on one part of it and so no solutions on the other part of it, right? So you're going to see what that means. And then setting up test points on your graph is kind of like what I just described. That's how we're going to find out where our solutions are going to lie. Alright, so let's get started. Number 1 is already a quadratic in standard form. Right, we have the quadratic on one side, and we have an inequality symbol and 0 on the other. Alright, so we're going to factor it the same way that we would a regular quadratic equation. Right, so we're going to get x minus 3 and x plus 1. And I'm going to write that this is equal to 0, even though we're not going to have equals 0 in our solution. Like our x equals 3 and x equals negative 1 are not going to be our solutions, right? We call those critical values, right? So I'm going to graph these numbers on the number line, and that should give us kind of 3 different sections, right? So you see right here on the number line, negative 1 and 3, it's going to partition our number line into 3 different sections, right? So at negative 1, we kind of split it, and at 3, we split it as well. So we have 3 sections, and what we're going to do is we're going to pick values to test if each little section is a solution. Right, the easiest one to pick is going to be 0, right? And where is 0 on our number line is going to be between negative 1 and 3, right? So I'm going to pick 0, and if it's in the second interval, then we're testing for that entire section, right? Now 0 is nice because you see that we're kind of canceling a lot of things out. We get 0 squared minus 2 times 0 minus 3 is less than 0. And then we get negative 3 is less than 0. That means that it's a solution for the entire section. Negative 3 is less than 0 is a true statement. So that means that entire section is solution. And because we have a strict inequality, we're going to have open circles. And so that means also that the sections to the right and to the left are not going to be solutions, right? So our solutions are going to alternate. We're either going to have that we have solutions on either end of our critical values, or we're going to have values in between, all right? And now when we write our answer in interval notation is going to be from negative 1 to 3, not including those values, so we're going to have parentheses around them. And let's keep going. We're going to do number 2 now. Number 2 is very similar to number 1, right? We have an inequality symbol, and on one side of the inequality symbol we have a 0, and on the other side we have our quadratic. Right, so let's just solve it the same way. Right, let's find our critical values first. So factor your quadratic. It's going to be x minus 3 times x plus 2. Right, and I'm going to write equals 0 just because we're using these values to plot on our number line. We're not actually counting them as solutions. So we get x equals 3 as one of our critical values and x equals negative 2 as another. All right, so let's draw a number line. All right, we're going to have a point right here at negative 2, and we're going to have a point right here at 3. All right, we're going to have open circles since it's a strict inequality. And let's test a value. So again, I'm going to pick 0, and 0 is between negative 2 and 3. So I'm going to plug in 0, so we get 0 squared minus 0 minus 6 is less than 0. All right, and this is going to give us negative 6 is less than 0, and this is true. If it's true, we're going to shade in between the negative 2 and the 3. We're going to shade wherever the 0 is, wherever we had a solution. All right, and that's our answer as a graph. Now to write your answer in interval notation, you're going to go from left to right. From the very left, we're going to have a solution at negative 2. And our solution set is going to end at 3. And because we have open circles, we're going to have parentheses. All right, so in yellow is our answer in interval notation. All right, let's look at number 3. All right, again, just like the others, we have a 0 on one side and we have our quadratic on the other. So let's factor it and solve. X squared minus x minus 20 is going to factor into an x minus 5. And an x plus 4. Right, so I'm going to set this equal to 0 just to find your critical values, and then you get a critical value at 5 and at negative 4. All right, so let's write a number line. So I'm going to plot right here negative 4. I'm going to plot right here 5. And again, pick any value. I'm going to pick 0 again. And 0 is between negative 4 and 5, so it's going to be in the second section right here. And when you go to plug in 0, we get 0 squared minus 0 minus 20 is greater than or equal to 0. All right, and let's see if this is true. We get negative 20 is greater than or equal to 0. That is not true. Right, since it is not true, we will not be shading in between the negative 4 and the 5, but we will be shading in either direction. So we're going to have a solution over here, and we're going to have a solution over here. All right, and because we have equality in our inequality, right, it's a greater than or equal to, we're going to have closed circles. All right, so here's our solution as a graph. And now to write our answer in interval notation, notice we have two intervals here, right? We have two parts of our number line where there are solutions, and there's a gap in between them, right? So I'm going to write the interval for one of them, right? So for the left side, we're going to start at negative infinity. Again, going all the way from the left to the right, right? All the way to the left, we're going to start at negative infinity. There's no smallest number that we can pick. All right, so it's going to be negative infinity up to negative 4, and it's a closed circle, so it's going to be a bracket. Our next interval is going to start at 5. We have a gap, so it's going to be 5 up to infinity, right? There's no highest value that we can go. We can go as far right as we want. And because we have two intervals in the same solution, we want to join them with a u, the union. Again, this u means the union of two intervals, right? We're joining them together in the same solution. All right. And now let's look at the fourth one. We have 4x squared minus 5x minus 6 is greater than 0. All right, so let's go ahead and try to factor it. So let's do 4 times negative 6, right? Because there's something in front of the x squared, this is how we're going to do it. We're going to do 4 times negative 6 is negative 24. So we're looking for numbers that multiply to negative 24 and add to negative 5. And it's going to be negative 8 and positive 3. All right, so let's split up our middle term. It's going to become minus 8x plus 3x. Bring down the 6. Bring down the 4x squared. And I'm going to set it equal to 0 just to find your critical values. All right, and now let's group. Now that we have 4 terms, let's group, and we're going to pull out the GCF from each group. So we can take out a 4x from our first group. We have an x minus 2. And we could pull out a 3 from our second group, and we're also left with an x minus 2. All right, and now that the insides match, let's pull that out as a GCF. And we're going to be left with 4x plus 3, all right, in our other factor. All right, so setting each of these equal to 0, we get x equals 2 and x equals negative 3/4. All right, you can verify it and solve it if you want to. You should get the same answer. All right, and now these are not solutions, like I say, but these are critical values. We're going to plot them on a number line, and we're going to use them to split up our number line into 3 parts. All right, so we have a point right here at -3/4, and we have a point right here at 2. All right, and so we're going to, again, pick any value to test, right? I'm going to pick 0 as always. Right? If you can pick 0, pick 0. The only time when you're not going to want to pick 0 is if it already is one of your critical values. So let's say I had x equals 0, right? That's not going to tell us anything about our inequality. So you're going to want to pick a value. Let's say we had 0 and 2 as our critical values. You're going to want to pick something between them or something on the outside of them, right? It doesn't always have to be in between, right? As long as you know where it is and as long as you know where to plot your solutions. All right, so sorry, let me go ahead and erase that. Yeah, let's plug in 0. So we get 4 times 0 squared minus 5 times 0 minus 6 is greater than 0. And then everything here cancels out, so we get -6 is greater than 0, and that is not true. So that means we're not going to have solutions in between -3/4 and 2, but they're going to go in either direction. All right, so we're going to have open circles that are critical values since it is a strict inequality, right? And again, going in either direction. All right, so what you see in green is your answer as a graph. Now let's write our answer in interval notation. Going from left to right, we're going to start at -infinity, and we're going to go up to -3/4. Right, and it's an open circle, so it's going to be a parentheses. All right, we're going to join it with our next interval. So I'm going to write a u, parentheses, because it's an open circle, 2, infinity. All right, with the parentheses. And then there's your answer in interval notation. All right, now moving on to number 5. This one looks like something that's not in standard form. All right, so the way it's written, you can't really do anything with it. So what you're going to want to do is you're going to want to turn it into a quadratic. Or I mean a quadratic in standard form, right? This is a quadratic, but let's distribute the x. Right, so we get x squared plus x is less than 12. And let's move the 12 to the other side so that we can have it in standard form. So we get x squared plus x minus 12 is less than 0. All right, now that it's written in this way, we're able to factor it the same way as always. All right, so let's factor it. We're going to find what multiplies to -12 and adds to 1 is going to be a +4 and a -3. And then set this equal to 0 to find your critical value. So you get x equals -4 and x equals 3. And now let's plot these values on a number line. All right, so we're going to have a critical value at -4, and we're going to have another one at 3. All right, now let's pick a value. I'm just going to show you guys that you don't always have to pick 0. You can pick any other value that's not in between, but I'll show you guys that if you pick a value that's not in between, what that means. So I'm going to pick 4, right? 4, where's 4 with respect to our numbers? It's going to be right here. Right, it's going to be after the 3 in our third little section, right? So I'm going to plug in 4 into our original inequality. We get 4 times 4 plus 1 is less than 12. 4 plus 1 is 5, so we get 4 times 5 is less than 12, so we get 20 is less than 12. Let's see if that's true. Is it? No, right? That's not true. Right, so that means this entire section is not a solution, and this section is also not a solution. Remember, they alternate. If it's not going to go on the outside of your critical values, then it has to be a solution in between. Right, and you would have gotten the same thing if you checked 0, right? If you plugged in 0 into your original inequality, you would have gotten 0 times 0 plus 1 is less than 12, and that does work. All right, so we still end up shading the same area. Since it is a strict inequality, it's going to be an open circle. And to write our answer in interval notation going from left to right, our leftmost value is going to be at -4, and our rightmost value is going to be at 3. All right, and since we have open circles, we're going to write parentheses around these values. All right. And now moving on to number 6. Again, it's not a quadratic in standard form, but it doesn't have to be. Right, so in this case, it's actually easier to just square root both sides and then get your two answers there, or your two critical values, sorry. So we get x equals plus or minus 4. Right, that's the really important thing here is you don't want to forget the plus or minus because then you're only going to get one critical value. And with quadratic inequalities, that doesn't make any sense. Right, so at least in this case, right, we don't have any repeated values or anything. We have just a -4 and a 4. All right, so again, let's pick a value to test. I'm gonna pick 0. Right, so I pick 0 right there, and when you plug it in, you get 0 squared is greater than or equal to 16, and that's not true. 0 is not greater than or equal to 16. So the entire middle section is not going to work. You're going to want to shade on the outside, right, in either direction. All right, and since we have the equality underneath, we're going to have closed circles. All right, and then we want to answer this also in interval notation. So starting all the way from the left, we're going to start from -infinity, and we're going to go up to -4. Since it's a closed circle, we're going to want to write a bracket. All right, since we're joining this with another interval, we're going to write a union. And then our next interval starts at 4, including, because it's a closed circle, so it's a bracket, and we're going up to infinity. All right, so this in yellow is your answer in interval notation. All right, so these last two examples are a little bit trickier, right? Why don't we give them a try? All right, so number 7. As always, if you see a quadratic inequality, you want to write it with 0 on one side and your quadratic on the other, right? So here, let's first add the 1 before we do anything else. So we get x squared plus 4x plus 1 is greater than 0. All right, and now you want to check, can you factor this? This one cannot be factored. We don't have two whole numbers or integers that can multiply to 1 and add to +4. All right, so what you're going to do instead is you're going to either complete the square or use quadratic formula. Right, I'm going to complete the square. So off to the side over here, I'm going to do x squared plus 4x, right, leave a little space, equals -1 plus, leave a little space. I got questions in class, why is it a -1? Or it was originally a -1. Right? You had to move the 1 to put it on the other side, but I'm going to move it back since I'm completing the square. And then you want to get your b over 2 squared, right? So 4 over 2 squared equals 2 squared, and 2 squared is 4, so we're going to add 4 on both sides. All right, and then x squared plus 4x plus 4, that's a perfect square trinomial, so it's going to be x plus b over 2, which is x plus 2. Squared, and then -1 plus 4 is 3. All right, and then now you just want to square root both sides, and so you get x plus 2 equals plus or minus the square root of 3. And now let's subtract 2 on both sides. So we get x is -2 plus or minus the square root of 3. So this is one example where I actually really like completing the square. Typically, I'm not the biggest fan because it's not really applicable in every single case. I mean, it is applicable in every case, you just don't, or in almost every case, but there's some where it's going to make your work so much more difficult. Whereas here, if you use the quadratic formula, right, I'll even do this work off to the side. We get a equals 1, b equals 4, and c equals 1, right? You're just using a, b, and c in your quadratic and standard form. So we're going to get x equals -4 plus or minus the square root of 4 squared minus 4 times 1 times 1 all over 2 times 1. And so we get x equals negative 4 plus or minus the square root of 16 minus 4 over 2. And we get x is negative 4 plus or minus the square root of 12 over 2. And then the square root of 12 you can simplify. It becomes the square root of 4 and the square root of 3. And so we get x equals negative 4 plus or minus 2 square root of 3 over 2. All right, now this is the part that some kids mess up, which is why if you're able to complete the square, I would do it. Some kids mess this up, but because this 2, or because your terms on top are both divisible by the 2 on the bottom, then you're able to divide everything by 2. All right, so that goes away, and then we just get negative 2 plus or minus a 1 square root of 3, which is just the square root of 3. And notice that we get the same answer, right? The quadratic formula is reliable. You can use it in every single quadratic equation that you have, right? But just sometimes if there's a slightly faster way to do it, then it's better to know all the ways, right? Just so that you're not spending so much time working it out that way, right? But anyway, now that we did that, the whole point of doing that was that we get our two critical values, right? We get one of them is negative 2 plus the square root of 3, and we get negative 2 minus the square root of 3. Right, so let's plot this on a number line. I'm going to do it right over here. One of our values, our smaller one is going to be negative 2 minus the square root of 3. And our bigger one is going to be negative 2 plus the square root of 3. Right, so hopefully we see that, right? If you're adding some weird radical number to a number, it's going to be bigger than if you were to subtract it, right? That's not a super difficult concept to grasp. Now, the tricky part here is picking your value, right? Now, I know we typically pick 0. You can still pick 0 here, just a lot of kids make the mistake that if you pick 0, it's going to have to go in between these two values here, right? And that's not the case here, right? 0 does not go there. 0 is actually going to go somewhere over here, right? It's going to go right here, right? And one way that you can think about it is the square root of 3 is less than the square root of 4, right? So if I have negative 2 plus the square root of 4, that would definitely be bigger than negative 2 plus the square root of 3, right? Because 4 is bigger than 3, just they're both under a radical, right? So then we get negative 2 plus, the square root of 4 is 2. Negative 2 plus 2 is 0, right? And if that's bigger than negative 2 plus the square root of 3, then it has to go to the right of it, right? So if you're testing 0, you're actually going to be testing for the outer parts, the outer sections of your critical values, right? The other thing that you could do, all right, let me erase the 0, right? The other thing that you could do is pick a different value, right? I actually like here, I would pick negative 2, right? And the reason I would pick negative 2 is because you know for sure it's going to be between negative 2 minus the square root of 3 and negative 2 plus the square root of 3, right? If you're adding something to a number, let's just do, for example, negative 2 minus 1 and negative 2 plus 1, right? If you're subtracting 1 and adding 1, negative 2 for sure has to be between these two, right? Because you're taking the exact same number and you're just adding and subtracting it to this number here, right? So it's going to be dead in the middle of it, right? So that's one way that you can think about it. The other thing that you can do is maybe you don't want to think about any of that and you want to pick a value that you know for sure without having to give it much thought is going to work. Maybe you want to pick a value all the way over here like a 20 or something like that. You can probably guess that that's going to be bigger than negative 2 plus the square root of 3, right? And it's definitely going to be a worthy contender for that section of your number line, right? But you don't have to do that, right? There's other ways to do it to make it easier on yourself. So okay, enough on that. Let's go ahead and actually test a value, right? So we're going to plug in negative 2 squared, right, plus 4 times negative 2 is greater than negative 1. And let's see if this works, right? So we get 4 minus 8 is greater than -1. So we get -4 is greater than -1, and that's not true, right? So if you had plugged in 0, you would have seen that it worked, right? And if it works, then it works for this entire section, and it works for this entire section. We're going to the left and right of our critical values, all right? And because it's a strict inequality, we're going to have open circles, all right? So again, since -2 didn't work, it's not going to work for the entire middle section. We have to go on the outside of it. All right, now let's write our answer in interval notation. Starting from the left, we're going to start at -infinity, and we're going to go up to -2 minus the square root of 3. Union, we're going to start again at -2 plus the square root of 3 to infinity. Right, and we have parentheses here because of the open circles. Right, and we're starting at -infinity and going to infinity with the gap in the middle. All right. And now let's try number 8. Let's finish strong, right? So let's add 48 to both sides, right? This isn't even a quadratic, right? But we're going to solve it the same way, right? So we're going to have 2x cubed minus 3x squared minus 32x plus 48 is greater than 0. And then because we have 4 terms, we can factor by grouping, right? So let's group the first 2, group the second 2. We can take out an x squared, and we're left with 2x minus 3. We can take out a -16, and we're left with 2x minus 3. And I'm going to write equals 0. All right, and we get x squared minus 16 equals 0. 2x minus 3 equals 0. So we get x is plus or minus 4, right? We just add 16 and then square root both sides, adding a plus or minus. And then we get x equals 3/2, right? Add 3 on both sides and then divide by 2. And then let's write on our number line. We have 3 critical values now, right? We're going to have a -4, a 3/2, and a 4. Right, now let's pick a value. Here we can pick 0 as always, right? It's not super difficult to know where it's going to go. It's definitely going to go between the negative and the positive, right? So it's going to go right here, somewhere around there. Let's plug it in and see if this is a true statement. So we get 2 times 0 cubed minus 3 times 0 squared minus 32 times 0 is greater than -48. And then everything over here turns to 0. And so you get 0 is greater than -48. Right, so that means this entire section works. All right. Now, that means, just like with quadratics, if this section works, the sections beside it are not going to work, but it's going to alternate. So the one after 4 is going to work. All right, so 4 onwards is going to work. And we have a strict inequality, so we're going to have open circles everywhere. Now, I'll let you guys know now. The only way that it won't work where it won't alternate is you're going to have to check if you get a repeated critical value. Let's say you got -4 twice, right? You're going to have to check that either side of that -4 would be a solution, right? And we can talk more about that as we come across it, right? But that's just something to keep in mind. But because nothing here repeats, right, all of our critical values show up once, we know it's going to follow the pattern of alternating. Right, so let's now write our answer in interval notation. Going all the way from the left to the right, we're going to start at -4 with a parentheses. We're going to end this interval at at 3/2 with a parentheses because it's an open circle. Union, we're going to start again at 4, and we're going to go all the way to infinity with the parentheses. All right, and that's all you have to do for that one.